Hey guys, so we're going to look at this last topic in this unit where we're verifying inverses. So if two functions are inverses, okay, there's two ways to determine if they're inverses of each other. So for example, an inverse of an operation, you already know those. The inverse of addition is subtraction. The inverse of multiplication is division. So if we square something, the inverse of squaring something is to square root something. So those are examples of inverses. So when we have a graph, determine if the following graphs are inverses. So here's one of our graphs right here. Okay. It says notice the two graphs are symmetrical about the line y equals x. So here's your line y equals x. Okay, so let's take this point right here. This point right here is -1, +1. Now if we flip it over the line y equals x, the new point is +1, -1. So see what happened? These two, the x and the y, they changed position. So the x value became the y, and the y value became the x. Let's look at another point. So here we have 0, 5. So the inverse point should be 5, 0. 5, 0. So to find the inverse of a graph, we just take some points, some nice pretty points, and we switch the x and the y and plot them. Switch the x and the y. This is very important to remember. This is a key concept here when it comes to finding an inverse, switching the x and the y. So when you're given a graph, you switch the x and the y for some points, and then that will plot your inverse graph. So let's take a look at number 2. Okay, so it says determine if the two functions are inverses by graphing. So the first thing we want to do is to graph these two functions. Well, they're both linear. We know how to graph a linear function. We start off with the y-intercept of +2, and then we apply the slope, which is in the form of rise over run. So we rise 1 and we run 3. Rise 1, run 3. And we do that both directions. So this time we're going to go down 1, left 3, the opposite. Okay, and then we look for straight edge. I'm just going to use my paper here because I don't have one handy. And we draw our line in. Okay, so that's going to be function f. Okay, graphing function g, we have a y-intercept of -2. If we were using transformations, this would be translated 2 units down. Notice down 2. And then this would be a vertical stretch. So you can do the slope thing, or you could do the vertical stretch thing as well. So let's just go ahead and do rise over run. So 3 up, 1 over. To the right, 1, 2, 3, 1 right. And then the opposite direction. And make draw a line through those points. Draw a line. And this is function g. Now, remember up here it says in order for two graphs to be symmetrical, they need to be symmetrical, or inverses. They need to be symmetrical about the line y equals x. So if we draw in the line y equals x, which goes directly through the origin, okay, notice that they're not symmetrical about the line y equals x. And we can prove this by just picking a point. Let's pick this point right here. That's going to be -3, +1. So the inverse of that point is 1, -3. So if I go to 1, -3, notice there's nothing there. So these two functions are not inverses. Okay, that's graphically. Now we're going to take a look at algebraically. So to determine algebraically if the two functions are inverses, what we need to do here is we need to do a composition. What we're going to do is we're going to plug one function into the other and then simplify it, and if the result is x, then g is the inverse of f. So let's go ahead and do this. Let's plug function g into function f. So here's function f. We're going to plug function g in. And then we're going to simplify. There it is, x. So when you simplify it and the result is x, then you know that g is the inverse of f. Now let's find out if f is the inverse of g. So this time we're going to plug function f into function g. So here's function g. We're plugging in function f in. And then we're going to simplify. And there you go, we got x. So anytime you simplify and you get x, then you know that these two functions are inverses. If you get anything else, a negative x, a 2x, an x plus 4, anything else, then they are not inverses of each other. Okay? Well, I hope you guys are having a great evening. We'll see you tomorrow. Don't forget to join Google Classroom if you haven't and answer that question.